I've spent the last week and multiple kilos of filament 3D printing 16 of the most clever, ingenious tools from across 4 different categories. I'm pretty sure that 3 of them are going to seriously level up the types of projects that I can do in this small workshop. And I'm hoping that the last 3 will solve some seriously annoying problems that have been bugging me ever since I was a kid. But some of them, well, they may not be worth the filament. So together, we're gonna test them out. Let's get after it. Let's start our list off with some of the smaller and easier prints, and then work our way up to the more complicated and filament-intensive ones. First on the list, we have this very clever contour gauge profile duplicator by iLab. At just 61 grams of filament and around 4 print hours, it adds a real and useful capability that many of us probably don't have in our workshops: the ability to trace contours onto a piece of paper. Now, it doesn't sound all that useful, I admit, but if you've ever needed to model or cut something like flooring or wall tiles, then you know just how useful a device like this can be. Perhaps best of all, it uses absolutely zero outside hardware, relying fully on a 3D printed screw and nut to be fully adjustable for different size pens and even different distances. Now, my only feedback here is that the multicolor profile that was provided wasn't actually multicolor, at least not in Orca Slicer, and that the sharp lip could really use some mouse ears to keep it down to the bed. It also does use a ton of supports, but I just printed it on the Prusa Index, which allowed me to do multicolor and multi-material, and the supports came away just fine. By the way, I am just gonna say this once and then we'll get it out of the way for the entire video. We are going to link all of these designs down in the description, so make sure you check it out and maybe give a guy a like while you're down there. If you like that tool, then you are going to absolutely love this one. So have you ever been sketching out a design or a floor plan on a piece of paper and wanted to create nice, clean dotted lines? I actually had this exact urge just the other day. So you can imagine my excitement when I discovered this mechanical dotted line pen by It's On My Mind. Now, it uses one of 2 replaceable gears to bump the pen up and down in either a dashed or a line and dash pattern. And this is especially cool because in our digital era, it's actually become pretty difficult to find store-bought versions of this tool. There's really only one on Amazon right now with no reviews, and even that was only added recently. So while the designer admits that this tool can be a little bit finicky in terms of pen types and speeds, I just think that it is so cool that 3D printing can enable us to make our own tools when it's no longer economically viable for the manufacturers to make them at scale. Another example of exactly that is this quick grip clamp joiner by LayeredbyJB. So apparently, Irwin, the maker of those quick grip clamps, used to sell a tool to extend 2 of their shorter clamps into one much longer one, so you wouldn't have to buy another extra long clamp. And one can only wonder why they would stop selling such a clever little device, but they did. So instead, LayeredbyJB created this lovely little guy, which does the same thing. Now, he recommends that you pick up some M6 thumb screws, but honestly, I'm just gonna go ahead and make my own. For strength, I personally chose to print this out of Prusament PC Blend, but I'm pretty sure that they'd be pretty darn strong out of PETG as well. Just do make sure that you avoid the temptation to print this one standing up to try and minimize the amount of supports, because you definitely want the layers to run horizontally or longwise for that added strength. One tool that you definitely can buy in every hardware store is a stud finder. But I don't know about all of you, I've literally never had a good experience with one of these things. Maybe you need to buy a really, really high quality, expensive one to get reliable results, but that just doesn't make sense if you, like me, only need it once in a blue moon. So what if we could just 3D print one instead? I know, I'm super skeptical as well, but it just might work. See, with the Stud Sniffer 3000, designer wuboo has basically created a big, honking magnet and then attached it to a nice little joystick that serves as an indicator whenever the magnet finds metal. Now, he claims that it can detect pieces of metal as small as screws or nails embedded in the studs, but if you're like me and you don't live in America, it might actually work even better because here in the Holy Land, we use metal uprights instead of wooden studs. That's the hope anyways. There's really only one way to find out if this thing's actually worth a damn, so let's go find some studs. Okay, seriously this time. Come on. Oh, what? No way. Oh, look at that. It actually works. With the simple and easy to print stuff out of the way, let's go ahead and work our way up in complexity here with some mechanical marvels to make things easier around your workshop. First, we have this lab jack by StinkWeasel. I'm gonna be real with you guys, like many of the commenters on this models page, I actually have no idea what the average person would actually use this thing for, but for me, it can solve a whole lot of little inconveniences related to filming. And honestly, even if you don't do a lot of filming, the possibilities with this one are endless. You could use it to micro adjust your laser level. You could use it to prop things up a little bit higher, or do as some people in the comments have done and scale it up to 200% and actually use it to hold up entire work pieces so you don't have to crane your neck on the table. But what makes this design truly ingenious is the fact that it's print in place. The author has provided a few different profiles that use around 100 grams and take anywhere between 4 and 7.5 hours to print. But personally, I decided to print it real nice and slow with very thick walls and a ton of infill so that it would hopefully be strong despite being only printed out of PLA Pro. I am a little worried though, because a bunch of folks in the comments did manage to break theirs during the initial cracking open of the print in place mechanism. So here goes nothing. Please don't break. Please don't break. Ah, yeah. Okay, yeah, so I broke it, but I'm still not ready to give up on this.
The next day.
All right, I am back, and I have this. It is 200% scaled up, printed at 0.15 millimeter layer heights, and it took 22.5 hours, and yet still, I almost broke it. You can see here, it's a little bit bent inside. And what I realized is it was not the actual scissor mechanism that was causing the last one to break. It was actually that I had printed with a brim, and for some reason the brim also went inside, and these back panels that were on the bed, which I had printed with the brim so it wouldn't get knocked over, those were bonded together. Once I cut those, everything cracked open and bent a little bit inside the mechanism, but this works great. And wow, it is going to be very useful. This is super cool. I would just say definitely avoid the brim. Print maybe a test cross section to check your printer's parameters, but also I think it's more useful at this 200% size. And in retrospect, I should have just started with the big one because the original one is really quite small. This is exactly what I wanted though. Fantastic. And it will allow me to prop stuff up exactly where I want it. Really cool. So that one will definitely come in handy if I need to prop something up. But what if I need to secure it to something else, like on the ceiling? Sure, paracord and steel guy wire are pretty cheap and readily available, but they're not exactly pretty for your projects. But honestly, who am I kidding? I'm just making excuses because I absolutely had to print out this awesome cord maker by Jeff M. With just 300 grams of filament and 10.5 hours, plus a little bit of assembly work, the promise is that you can have your very own cord making device, which basically uses clever gears and a drill bit attachment to speed up making beautiful cord out of a wide variety of things. And come on, don't kid yourself. You've always wanted to be able to make these beautiful custom cords for various projects, or say beautifully wrap the wires for your 3D printer projects. No? Just me? Whatever, it's my video and this is what we're doing right now. So come on, let's go try this thing out. I don't think I did this right. Maybe this was supposed to start at the other side? Why is this tangling to that? PLA, probably not the right choice here. Yeah, it's melted. Nice idea, needs better directions, especially in terms of mounting all the different wires, and maybe a warning not to print in PLA, though that's probably common sense. Speaking of making things more beautiful, you know what I absolutely hate? When you paint a wall or a room and the masking tape isn't perfectly straight, causing these ugly wavy lines despite you spending hours carefully placing the tape by hand, but no more, hopefully, thanks to this masking tape applicator by MIO. Yes, it requires 382 grams of filament and around 12 hours to print, but in return, it boasts a lot of very cool features. First, it's designed to run flush against walls, trim, or components. It includes spacers to perfectly position line tape roll on the axis, and it even uses 608 bearings for smooth operation. It's also adjustable for different tape rolls, and perhaps best of all, it has a built-in cutter on both ends, so you get quick, straight cuts instead of the awful tears that cause paint to leak anywhere. As you can tell, I am pretty excited about this thing, so much so that I might just get some of the painting work done that I've been putting off for ages. If you're watching this video and thinking to yourself, dude, my 3D printer could never. That thing is always breaking or needing all kinds of maintenance. Well, then I recommend that you check out the 3D printers from this video's sponsor, Prusa Research. I've been a huge fan of Prusa printers long before I had this YouTube channel for one simple reason. I believe in their ethos. I guess, honestly, two reasons, because I also have always had a great experience with their products. They're super rugged, they're built to last, and you can upgrade them infinitely, not just because they're open source and community focused, but also because Prusa releases upgrades every time they come out with a new printer. So you can really look at your Prusa printer as a lifetime investment. And if you need to do more advanced things with it, like print 450°C materials or print 8 different colors in the same print, they've got upgrades for that too. So to check out Prusa's entire line of 3D printers, visit the link in the description. And now, let's get back to the video. All right, with the hand tools and mechanical gadgets out of the way, we're finally ready to move on up to my power tools section, which features a bunch of accessories that will transform or otherwise upgrade your power tools to have new and unique functionality. First, we've got this blower booster by TIMakes. Essentially, it twists onto your Makita blower and harnesses the power of the Venturi effect to, at least theoretically, blow more air than the blower alone can produce, albeit at a lower velocity. At least that's the theory. Scrolling through the comments, some folks aren't sure if this thing actually works. If it does, it's a huge win for just 250 grams of filament and 7 hours. And since I get filament for free, thanks to Sunlu, I figured that I would just try it out for all of you. However, before I do have a little bit of a bone to pick with the designer of this model, TIMakes. Currently, this model is uploaded under a standard digital file license, which means that nobody can share a remixed or improved version if, say, it doesn't fit their exact model of blower. And look, I get it. Makita tools are the best and all the other brands can go kick rocks. But still, what do you lose by just letting people improve your already free design for personal use? All right, let me step down off my little soapbox here and we'll go ahead and head out to my backyard and see whether or not this thing blows. Up next, we have this very clever little rotary tool Dremel screw cutter by 4-3D Print. Now, actually, I have to be honest here. I did back a full Kickstarter, which was actually quite similar to this and would turn your Dremel tool into all sorts of tools like a belt sander, a plunge router, a mini table saw, and even a drill press. But then I ultimately decided that it was way more printing and assembly work than it was worth for me, given that, I already have an actual table saw, a plunge router, a drill press, etc. So what caught my eye about this dedicated screw cutter was actually the simplicity of it. It's a very, very simple tool with only a handful of parts to print and assemble for a very specific and common use case. A use case that's actually best served by the diamond cutting wheels available for Dremel tools. Because I don't know about all of you, but this Motherland just doesn't feel all that safe to me. I particularly like how it uses a rubber band and a fixed rotating axis printed out of polycarbonate to make the cuts straight and clean, so you don't muddy up the threads of the screw. With that said, I do have two pieces of feedback here. First, it seems like a real missed opportunity to not add ruler measurements along the top so that you could just quickly adjust for your desired screw length. I'm probably just gonna pop this thing into the Xtool F2 fiber laser that I covered in a recent video and add those gradations. But it would be nice to have them 3D printable in the model. And second, I found myself wishing that there were attachments for cutting smooth rods as well as the threaded ones, because I recently had to cut a bunch of those for a project I did on the channel, and their smoothness made it a real pain to clamp them without damaging them. I may just model these up in Onshape myself, Onshape being our official CAD partner, and use some precisely sized holes, threaded inserts, and a grub screw to hold them in place, because 4-3D Print has licensed the model using the Creative Commons license, which we always appreciate. All right, who wants to go chop up some screws? Nah, you literally can't make this stuff up. The way that this is designed, it has to be right onto the bolt, and all of my cutting wheel attachments all have this shoulder, and I can't find one that is just directly on like this, so I don't actually have a way to test it. I wish the designer would have noted that or offered a different version where it was slid out. It's like 10 minutes to remix this in Blender or Onshape or whatever, but I can't test it. I either need to get one of these without this shoulder, or I need to remix this model. It's so annoying. Over, what, a 1 centimeter shoulder. I can't test this one. Another one of the tools offered in that big complex Kickstarter that I talked about was a belt sander, which I personally have actually never used or owned. So rather than spending $65 for a cheapo, low quality one just to see if it's something that I would use in my workflow, I decided to actually print this one by Marinade. It uses 451 grams of filament and 16 hours of print time, plus a whole bunch of hardware that I am going to need to order in. But all in all, it still comes in at like under $30. And honestly, the most appealing thing about it, for me at least, is that it will hopefully take up a whole lot less space than a dedicated belt sander, since you're using the motor from your drill. With that said, I am wary of a couple different things even before we get it assembled. Namely, I'm wondering if I'm gonna have to hold the drill and the trigger to the drill while I use this thing, or if I'll be able to kind of prop the drill up against the table and clamp the trigger at my desired speed so I have both hands available for sanding. Unfortunately though, we probably won't be able to actually test the full functionality of this in this video, since I am waiting on the sanding belt to arrive, but I do think that we can at least test the drill ergonomics of it out and do a dry run once we get it assembled. Okay, so I've got it mostly assembled, so I understand how it works. I already have some major concerns. There's not very good instructions. The instructions are just written. The pictures are not clear. It's all black plastic and you can't really see. He says things like mount it to the table. There's no way to mount it to the table. So that's not very clear. I think overall the design needs a little bit more work, and some things are just not well thought out. Like that's where the drill attaches, and that's just gonna snap if the drill's not perfectly aligned. I did see someone comment that they have made an adjustable drill trigger holder, so that will solve this. I do think this is maybe worth playing around with, but it does need some improvement in the instructions side at least. By the way, honorable mention goes to this 3D printed arbor press. I don't remember which video I printed this for. We'll link it down below, but this has proved so useful throughout assembling all these different things. Definitely worth printing. This is polycarbonate CF, so strong enough to, yeah, good. Up next, something that most of us probably don't have in our maker spaces, which is a router table. If you're like me, you've always been mesmerized by these things and intrigued by how they make using your router a bit safer and more predictable. But honestly, who has the space and the frequent enough use for a full-on router table? I certainly don't, and I imagine that most non-woodworkers are in the same boat. So imagine my excitement when I found this, a 3D printable one that takes up very minimal space on your table and can be easily stored. Now I'll admit, I'm pretty nervous about this one. On the one hand, I kind of assume that its size means that we're not going to be using it for very large things, and I sure as hell don't plan to hold very, very small things up to the most terrifying and unpredictable power tool in my entire arsenal. Perhaps for those mid-size workpieces, though, this could be really useful. Plus, I still have all sorts of concerns about stability with larger workpieces, the varying heights and different size batteries of my router, but what the heck. Let's go ahead and finish printing this beast of a thing out and see how comfortable we feel. Just before we do, just from looking at the provided 3MF, I do have notes. Namely, what's the deal with the honeycomb infill? It's so incredibly slow, and it's not appreciably stronger than any other 3D infill such as cubic. Also, it would have been really nice if the 3MF had supports already painted on, because you really don't actually need support on these small bridges, and with this glass fiber filament, it's going to be a real pain to get them out. But I'm not going to look a gift horse in the mouth, as long as it doesn't take one of my fingers off.
Honestly, not bad at all. My only complaint is I really would have liked to have, on my specific router, the buttons and controls facing forward, but not bad, honestly.
Now we just need one more power tool print to help us deal with all the dust and chips that is hopefully going to be making in the future. Which brings us to this vacuum cleaner Cyclone dust separator by Manu Tech Lab. I actually saw this on one of his YouTube videos, and it looked good enough that I decided to forgo all of the free ones on the various model repositories in favor of making an optional donation to Manu for this very, very cool one, and then printing it out. And oh boy, what a print it was. Because of the way it's designed, it requires a lot of supports on the main Cyclone body and on some of the other parts as well. Now, I'm not sure if it even could have been done another way, given the complexity of a two-stage Cyclone, plus the need to abide by those pesky laws of physics and flow dynamics. I opted to print mine out on the Prusa XL using PLA as a support material and clear PETG for the Cyclone and the container, and I think it turned out absolutely awesome, besides the fact that the mismatched materials caused the prime tower to fall over. But fortunately, we actually have a great solution for that problem coming up towards the end of the video, and honestly, the Prusa XL really didn't seem to care because this print turned out absolutely gorgeous. So now we need to go ahead and get it all assembled, figure out which of the many included adapters fit my vacuum and various power tools, and try it out. Let's go.
All right, so obviously I need to order more hose. I decided I don't want to damage the original hose of my shop vac, but why don't we go ahead and see what we dragged in here with this thing. It seems to have worked quite well. Oh yeah, look at that. Filtering out all the particles. And then it has two stages. Let's see what the first stage did, because that should trap some of the fine dust, if I can get it open. Oh, and we didn't even have the large filter in there. Oops. But let's see. All right. It's a good seal. All comes apart very nicely for cleaning. I should have printed this clear too. That doesn't have much in there, honestly. A little bit, but the main attraction is all this won't end up in your shop vac or your Dyson, which, you know, cannot really handle fine dust. I like it. I say it's a win. Actually, an even better use case would be to use it to protect my Hoto compressed air capsule. I can just fashion an adapter here, and then I won't have to take the shop vac out every single time that I want to clean out nasty dust, which destroys the filter of this, and I have to replace it all the time. Check it out. Actually works. That actually works. Yeah, that's probably a better use, is adapting non-shop vac to shop vac capabilities. Love it.
For our final section, I've got a handful of prints that I'm calling Kings of Convenience. Prints that will save you from a bunch of life's annoying hassles that you've probably been living with for years at this point. The next little annoyance I didn't know needed solving involves testing circuits. Because I gotta be honest, my dad taught me how to use a multimeter probably like 30 years ago, and not once did I ever think to myself, there has to be a better way than this. That is, until I saw the one-handed multimeter probe holder by Nilko. The name just about says it all, and if you've ever needed to test the voltage on something small, like a JST connector or a PCB, you will instantly see the value in it. Definitely worth keeping some of these around. Our next daily annoyance that you thought you had to put up with is putting a new trash bag into your trash can. I don't know about you, I really don't enjoy doing it, especially when it gets all poofed up with air, which is why the trash bag Snorkel by thomascb caught my eye. It promises to allow the air out of the bottom of the trash can, making the entire process seamless, dare I say even fun. And let me tell you friends, if this thing gets me to stop procrastinating putting trash bags in the trash can after I take out the trash, my wife is gonna be one very happy lady. All for like 79 grams of filament and less than 2 hours of print time. By the way, nice job Thomas for making this thing print flat without any supports. Now I've got this one printed out in PETG and we are going to need to take it back home to test it out. So let's go.
Is it actually letting the air out?
With snorkel, without snorkel.
And finally, I promised you guys that we would test out a solution to perhaps the biggest annoyance that a 3D printing enthusiast ever faces, which is failed prints due to detached supports or prime towers. Now in the past, I've tried gluing down the detached supports, but that only works if you catch it in time so that the gap isn't too big. Which is why this, the Print Saver Recovery Support Block by PrintinBad, takes it to a whole different level. No pun intended. Okay, maybe a little bit intended. Essentially, it's the ultimate dig your wells before you're thirsty 3D print. You print out this big honking block, which, by the way, my colleague Jacques discovered that you can do much faster if you enable vase mode. And then the next time you have either a support structure or prime tower detached, you spring into action like some sort of 3D printing commando, just cracking open a stim pack. All you have to do is look at the current height of the printer in the dashboard or measure it, snap the support block to that height or slightly below it, and double-sided tape it down to the bed. Your print will continue as normal rather than creating a build plate full of spaghetti. I will say that this block does use up a whole lot of filament, but it is the perfect way to use up a ton of near empty spools. Plus, if you crack off the topmost slat that you've already connected new supports to, you can basically reuse everything under it. Plus, I mean, think of all the 3D prints you're gonna save. Speaking of saving 3D prints, I want to encourage you to check out a recent video we did where we went over the 20-something most common reasons for print failures and print quality issues. And we actually teach you how to address each and every one of them. It's honestly like a full-on crash course in successful 3D printing packed into like 24 minutes, and I really think that you're gonna benefit from it. And if you're interested in 3D printing, don't forget to subscribe. 70% of you watching haven't done it yet, and it would mean a whole lot to me and my team if you guys did. That's all for this week, but I'll see all of you on the next layer.